In this video, we are going to be looking at the last topics of chapter 7, which is the energy present in chemical reactions. So when it comes to the energy in chemical reactions, understand that we are going to explore how energy is produced or even absorbed in chemical reactions. Understand that there are three conditions for a reaction to occur, okay? And they are the following. So, for a reaction to happen, your reactants must collide with one another. So, in other words, they need to meet one another. Now, not only they need to meet in the correct orientation because they need to align properly in order for some bonds to break and for other ones to form. Lastly, the collision must provide the energy required for activation. And as we're going to see, activation energy is going to be the energy that it has to be overcome by the reactants in order to form product. A very interesting and cool reaction that you can actually check online, there's many YouTube videos on it, is when sodium reacts with water. And it is something that you guys briefly explore in lab. This is a very exothermic reaction. And as you can see, that beaker pretty much generated a lot of heat and fire when water was placed with that sodium. Now, understand that in this reaction, because we saw a lot of heat generated, we even saw a flame, this is known as an exothermic reaction because heat was released, okay? Again, exo, you can think about it in terms of exit, and then thermic, you can think about it in terms of heat. So heat exiting, exothermic. So as you can see, understand that in an exothermic reaction, we are going to have heat as a product. So that's why you usually see it on the right side of the arrow. And one of the things is that it is important to note that the energy of the products is less than the energy of the reactants. And when it comes to this, we can actually illustrate it in an energy diagram. So the image that we have on the right side of the slide is actually what we call an energy diagram. And overall, what it's doing is plotting the progress of the reaction against the potential energy that we have of the different substances. So this is just relative energy. We don't have a specific amount here, but I want to explain the different parts of this energy diagram. First, we have the potential energy of the reactants. That will be around this area, okay? Then understand that as the reaction progresses, there's changes in energy, and at the top of that curve, we're going to have the activation energy. So the activation energy, as you can see, is going to be the difference between the energy of the reactants and the top of that hill. And that activation energy is the energy that reactants have to overcome to form product, okay? And in this case, because it is an exothermic reaction, notice that the energy of the products is actually lower than the one of the reactant. That's why it is down there. So the difference between, as you can see, the energy of the reactants and the reaction and the energy of the products is the heat of the reaction, and in this case is the energy that was released. Now, not every reaction is going to be exothermic, because we also in chemistry we have endothermic reactions. In endothermic, endo will be in, okay? So in endothermic processes, heat is going to be actually absorbed, okay? Typically, as you can see, heat in this case needs to be added to the reactants. That's why we have the units of heat in the reactant side on the left side of the arrow. And understand that in an endothermic process, the energy of the reactants is actually going to be lower than the energy of the products. So an endothermic process actually has a really high activation energy in order to get to products. Understand that one of the things that can be addressed through energy diagrams is the reaction rate. And the reaction rate, as you can see, is actually the speed in which reactants are used up. It can also be defined as the speed to which products are formed. Okay, there's certain things that affect the rate of the reaction, basically how we get from reactant to products, and those include temperature, okay, the concentration of reactants, and we're also going to see in a minute the use of a catalyst. So understand that the trend generally is that if you increase the temperature in a reaction, because now the molecules are going to move faster, that is going to be providing more collisions between the molecules, and that is going to be increasing the rate of the reaction. Another way that you can increase the rate of the reaction is by increasing the concentration of reactants. And again, if you have more reactants, they're going to have more time to meet. Now, another way in which we can increase the rate of the reaction is going to be with the use of a catalyst. Now, understand that catalysts, and we're going to see their use more often in later chapters, they are going to be increasing the rate of the reaction because they are going to be lowering the activation energy. So, as you can see here, we have a reaction in the blue line, okay, that it is proceeding. Now, if the same reaction is shown with a catalyst, so that means that it is a catalyzed reaction, notice that a catalyst does not change the potential energy. Of the reactants or products. The only thing that we see, and I'm just going to highlight it, is that it lowers the activation energy. So I always use the analogy of one of those races that are like mud races or Spartan races, that usually in those races at the end you have a big hill to overcome. It's usually a big platform that you need to climb. So all the catalyst is doing is that instead of climbing all of that, it actually reduces the height of it. So then you don't have to climb as high to still get to product. So it's really not changing the course of the reaction. It's literally just lowering the activation energy so you can get to product faster. Understand that a catalyst is not used up during the reaction. It is actually regenerated every time at the end, so it can continue making the reaction happen. So, as you can see, all of these factors that increase the rate of the reaction are summarized in table 7.8. So, as a summary, understand that when it comes to increasing reaction rate, the increase in reactant concentration causes more collisions, and that's why we have an increase in reaction rate. The increase of temperature creates more and more collisions with activation energy to actually get those reactants to products, and the addition of catalysts gets you to product by lowering the activation energy.